Okay, folks, so we're going to talk now about proving lines parallel. And if you remember from yesterday, we talked about if the lines were parallel, right, then the angles were congruent and or supplementary. Well, today we're going to talk about the converse of that. And in this situation, it talks about if the angles are congruent, then the lines are parallel. Okay, do you remember the conditional and then the converse? The conditional was if P, then Q. So the converse is if Q, then P. Exactly. So here's the converse of the corresponding angles theorem. This one reads that if 2 is congruent to 6, right, corresponding angles, then L is parallel to M. Okay? Because of it. That's right. Okay? All right, so then let's answer these questions right here. If two lines on the transversal form corresponding angles that are congruent, then the two lines are parallel. Very good. Okay. Use the diagram below to place the appropriate markings to show that angle 1 and angle 2 are congruent. Okay. 1 and 2 are congruent. How would we place markings there to make sure? We do the arc, but this would be 1 and 2 are congruent. Now, how would I show that perhaps this angle right here was congruent to this angle right here? We would do 2 marks, right? And then if I had a third pair, how many arcs would I do? 3 arcs. Very good. At the bottom here in 12, we want to circle the diagram that models 3-4. Now here's a good time for me to explain to you that 3-4 is pretty much irrelevant. Because if we were in a different textbook and this section was in chapter 4, it would be 4-4. Okay? So I don't want you to waste any time at all memorizing numbers. I want you to know the concept. Okay? Because I will never ask you if it's 3-4 or 3-2 or anything that has to do with the numbers. The postulates and theorems that have actual titles like vertical angle theorem will be always called vertical angle theorem. The ones that don't have titles, your book gives numbers, okay? But they are not official numbers for those theorems or postulates. They're just numbers that your book has assigned them, okay? So are we going to learn the numbers? No. Learn the concept, okay? And what we want to know is converse of the corresponding angle theorem, okay? So according to, not 3-4, but converse, right, of corresponding angles, which picture actually shows that? It's the second picture. Because the second picture actually shows corresponding angles. Now, just for fun, what type angle pair is 1 and 2 in the first picture? Alternate exterior. Very good. Okay. All right. Now, we had the converse of the corresponding angle theorem. We also have the converse of the alternate interior angle theorem and the converse of the same side interior angle postulate and the converse of the alternate exterior angle theorem. Okay? This one states that if alternate interior angles are congruent, then lines are parallel. If same side interior angles are supplementary, then lines are parallel, right? And then the last one is if alternate exterior angles are congruent, then lines are parallel. Yeah? So let's use some of those. Converse of the alternate interior angles theorem states that if two lines in a transversal form alternate interior angles then that are congruent, then the lines are parallel. Same side says if two lines in a transversal form same side interior angles that are supplementary, the lines are parallel. Okay? And then the converse of the alternate exterior angle theorem states that if two lines in a transversal form alternate exterior angles that are congruent, then the lines are parallel. Do you need to learn these numbers? No, do not worry about that. Just learn the concepts. Okay, just learn the concepts. And you don't even have to memorize the concepts because they'll be on the postulate and theorem sheet. You just have to know and understand how and when to use them. All right, so looking at theorem 3.5, which we know is the converse of the alternate interior angle theorem, if 4 is congruent to blank, B is parallel to C. Well, what would be the alternate interior angle? Would be angle 8. Very good, angle 8. Now, 3.6, which we know is going to be the same side interior angle. If 3 and blank are supplementary, then B and C are parallel. So 3 and 8 is correct. For 3.7, which is going to be the alternate exterior, right? 1 has to be congruent to what? 7. And if it is, then B and C are indeed parallel. Okay? Let's try a proof. Are you ready? Let's put it on notebook paper if you can't find it. Okay? 4 is congruent to 6. Let's prove that L is parallel to M. Okay? The first one would be what? 4 is congruent to 6. Good. And that's going to be what? The given. Okay? Now, what else do I need to say from here? 4 and, well, I don't need to say 2 and 4 are congruent because 4 and 6, I can use the converse, right? Oh, we're proving that theorem. You're right. We can't use it. Very good catch. Now I want to say that angle 2 is congruent to angle 4 because of what? Vertical angle theorem. Okay, you probably get more out of just watching and listening. Okay. The next thing I want to say from here is what? 2 is congruent to 6. Now, I really can't say transitive the way that I've written it, so I'm probably just going to need to say what? Substitution. Good. Almost. I have to now say what? First, I'm going to say 2 and 6 are what? Corresponding, right? I want to say that they're corresponding angles, okay? And that is by what? Definition of corresponding angles. Sorry. Okay. Now, once I've determined that they're corresponding angles, now I can say L is parallel to M, and that's going to be because, yes, converse of the corresponding angles. Good. So that would be, oops, I need a pen. Converse of corresponding angles theorem. Now you won't have to guess at the actual wording because you'll have the postulate and theorem sheet, so you'll be able to see. But you'll need to be familiar, again, with when to use which one. Okay? Now, why could we not use alternate interior angles as one of our reasons? Yeah, because that's what we were proving, right? So we couldn't use it because we were proving it. Now, if we weren't using that particular theorem as our proof, we could have used that. Trying to flip the page. Here we go. All right. So how about this one? Parallel lines. Okay. Now this is real important because when we have two sets of parallel lines, the parallel lines also act as transversals. So we have to be sure we understand what we're looking at. This one states that 1 and 2 are congruent. So if 1 and 2 are congruent, what is my parallel line pair and what is my transversal? Okay. If 1 and 2 are congruent, then my parallel lines are what? A and B. And my transversal is M. Okay? If I said that 3 and 8 were congruent, if I said 3 and 8 were congruent, what is my parallel line pair? L and M. And my transversal now is A. Do you see the difference? Okay, just be real careful because they'll catch us with that. Okay, so let's look at the question. 6 and 7 are congruent. Okay, is that given or is that what we're trying to prove? That's given. What kind of angle are they? 6 and 7 are alternate or same side? They're same side. 6 and 7 are on the same side of B. Are they corresponding exterior or interior angles? Corresponding, okay? I know with the numbers, okay? We'll have to check. Somebody look. Which one's 3, 2 and which one's 3, 4? I think 3, 2 is the corresponding one because it was the one we did first. Yeah. It is 3, 2, but we wanted to say corresponding angles, not 3, 2, okay? Okay. Now, according to 6 and 7 being congruent, which one is my transversal and which one are my parallel lines? 6 and 7. So which ones are the parallel lines? L and M. And which one's the transversal? B. Good job. Okay. Not exactly like that, no. Do what? Okay. So let's look at these right here where we're determining whether they are parallel or not. This one says that angle 1 and 2 are congruent. So if 1 and 2 are congruent, are R and S parallel? And how do we know? Okay, alternate exterior. Is there any other way that we could prove that? Well, 1 and 2 are alternate exterior, but 3 and 1 are corresponding. So if we said 1 and 2 is given, right? 2 and 3 are what? Vertical angles. And 1 and 3 are corresponding. Now, this would actually be because of substitution, though, right? And then they would be corresponding. Yeah, you're right. Okay, and they would be corresponding. Okay? All right, here's our last example. And in this one, the question's asked just a little bit differently. Okay? This one states that in order for A and B to be parallel, what would the value of X have to be? Okay? So in this situation, you say if A and B were parallel, these angles would be what? Not equal, supplementary, because they're same side interior. So you set them equal to 180 and you solve for X. So in order for A and B to be parallel, X would have to equal what? 30. Okay, so that's how you do that one. So let's look at this next one. Same concept, and it's this right here is exactly how the question would be asked. Do you see that? Okay. What is the value of W for which C is parallel to D? Okay. Well, what type of angles would they be? They're same side and they're corresponding, which makes them congruent. So I would say that 55 equals what? 3W minus 2. Okay? 57 equals 3W, so W equals what? Is it 19? Okay? So in order for C to be parallel to D, the value, right, of W would have to be what? 19. Okay? All right. I need you to do one favor for me. Turn to the page that has the proofs and make sure that you draw this picture, because this picture is not on that page and you need it to do those proofs. Okay? So you need to draw this picture.